my project is actually a timer alert system. Now, before anything, let's get the formalities out of the way. This is a VM account, this is my unique account, this is my software account, and this is my unique account. So the background to this, here in the top left corner, you can see the competency that is currently being addressed. The background for this is that my team is actually tasked with making a digital timer in a smart kitchen appliance. So the digital timer is needed to keep track of the cooking time, and once it comes down to 0, an alert must trigger. Now at this point, we were actually kind of concerned because as an engineer, we must address the safety aspect for our clients and the users. So we asked about them, and we discussed a bit about them to actually incorporate a temperature monitoring system. So if the temperature is excessive, the timer will stop and an alert will be triggered to inform the user that something has gone wrong. So here is the block diagram, and as you can see, it starts with a timer being turned on, and if the timer is turned off, it will stop, and then the user can do what they want to do. But if the timer is activated, but the temperature is way too high, it will trigger an alert as well, even though the timer has not reached 0, and then it will subsequently stop the timer. Now, the timer should count down from the preset right up to 0. Here we consider using either synchronous counter or asynchronous counter. Ultimately, we decided to use a synchronous counter because it provides more flexibility for the design aspect and also the end user, where you can put any sequence of numbers, whereas for the asynchronous counter, you can only put numbers in sequence. We converted this using a T-flip-flop circuit. Now this is a logic diagram for each flip-flop, and this is an excitation table of the flip-flop. And we designed the circuit based on this excitation table that we obtained from the next table. Then we designed the alert system, and the alert system has two tasks. It needs to be able to inform the user, and since nowadays people aren't always keeping their eye on their appliance, it must be able to attract the attention. So we incorporated both an audio cube and a visual cube, where the audio cube is a small speaker and the visual cube is a red LED. So in cases like the person is in another room, not in their kitchen, they will hear the sound, check it out, and immediately realize that it is indeed their timer going off. Then we incorporate the temperature monitoring system. The temperature monitoring system uses a temperature sensor to detect the temperature and change the analog signal into a digital signal using an ADC, which then can be incorporated into the whole system, which is digitally based. However, here we actually encountered a problem where we didn't have the sensor on hand. It's not installed. Immediately, we contacted our supplier, and unfortunately, they informed us that they cannot ship it to us in time to make a prototype to show to the client. So we contacted the client and we proposed to them that we can actually have a temporary replacement for what we are doing. And instead of using a temperature sensor, we can use another source of an analog signal that can be controlled. And next, we chose to use a potentiometer connected to a DC power supply so we can actually control the analog signal. In the final product, this potentiometer circuit will actually be changed into the temperature sensor. Here is the final circuit. You can see a synchronous counter, an ADC, and also the alert system. And the alert system is going off, the timer system is off because the temperature is way too high. Here you can see the alert system is actually off. And during our task, we managed to do a timeline using the Gantt chart. Now, at the end of the whole project, we found that the timer circuit is actually quite problematic and practical while it functions in simulation. So we shifted personnel from less urgent tasks into onto actually troubleshooting and